Welcome back to my 100 days of problem solving challenge. So, today is a day 6 of problem solving 100 days problem solving challenge. And today's we are going to pick up the question that is remove duplicate from sorted array. So, we have a given sorted array. We have to remove the duplicate in a place such that each element appear only once, and we are going to return the new length of that array. So let's see the example. Input 1 2 2 2 3 4 and output that new length that having a unique number 1 2 3 4. So we are going to see two approach. First is brute force and then optimize as usual, and at the end we are going to solve a question. Today we are going to solve the question in a LeetCode. So let's get start with the brute force. So what will the basic approach? We know about a set. What is a set? That set should have a unique number. So basically we are going to, for brute force, we are going to use the data structure HashSet. Rarely we can also use, but for this brute force we are going to use HashSet. So whatever the element we will directly insert to that set, it will automatically take only the unique number. It will automatically remove the duplicate element from that list. So the step 1, we directly insert all the value in a set, declare set, and we are directly at the end we will return the length of that size of that set. So here the time complexity will be n, because we are going to traverse each element and we are going to store, and the space complexity is also n, because we are going to declare one hash set with the size of n. So let's start in a VS Code coding for the brute force. So for the brute force, I already written the main method. I declared that array and I called a method remove duplicate, and whatever it will return the length of that new array, and I am going to store in a new length, and then I am going to print that new length. So this is our method. In this we are going to implement our business logic. So first approach will be always we will try to see what will be the edge case. False case means what will happen if num's length is null, if the length is 0. So we will, compiler will show compilation error at that time. So to avoid this we are going to handle the edge case first. So edge case will be like if num will be null or num's dot length equal to 0. In this case we are directly return 0. So by knowing that if the length, if this method is returning 0, means that something exception is happening. Now we are going to write our main logic. So now we are going to declare set of data type. In Java we are declaring set by using set keyword, and we are going to write the wrapper integer, because our set type basically will be the integer type. It has an integer value, so it will be name set is equal to new hash set. So the set is interface and hash set is a class. So we initialize our set. Now what we will do, we will traverse and we will directly put that value in our set. Int n equal to nums, and we just directly add that in a set. We will not check any condition, we will directly add. To add value in a set, there is a method add, built-in method. And here you can add all, you can use add all, you can use add normal add also you can use integer. Here the integer value we have to pass, so, and we are going to pass. Fine. Now at the end we will return that size of that set. Finish. So we're done with this brute force. We have declared one hash set, and then we directly put all the value in the hash set and then return that size of that set. So here the number of the element is what will be the length of that array before and after. We will going to see. So we will going to run this code java with the name of that class dot java. So here the output is old length is 7 and new length is 4. Before removing the duplicate element, the length of the size of that array is 7, and then we pass the value here in the method, and in this method we are going to put all the value in a set, and set automatically remove the duplicate element and it is store only unique element, and at the end we are going to return the length of that size of that array. Fine, thank you. We are getting the result here. Here the approach is same. Nothing we are doing, we are just storing the value in a set and we are just returning the size of that array. So here the space is n because we are declared this hash set of size n. So that's why time complexity is n and this space complexity is n, and time complexity is also n because we are traversing with the for loop. Now we are going to see the optimized approach for this solution. So what will be the optimized approach? Basically we are going to use two pointer technique. With the two pointer technique we can solve most of the array problem related questions. So here we are going to take two pointer. First pointer is I, second pointer is j. As per your choice you can take p1, p2, left, right, anything. Since we know that our array is sorted order, so the next number will be a duplicate if the duplicate element is present. If it is not, then will be unique. So most probably the next element means neighbor will be a same number. So what we will do, we will check the conditions, like what will happen if both the number we found is a means different. If the both number means 1 and 2 neighbor, here 1 and 2 both are different number. So in the different number we get to know that if the neighbor is different, then it is a new unique value. If neighbor is same, so when we found the unique number, we will move the I value and copy the I value. We will going to implement that first the visualization and then we will jump to the code. So let's start with the here step 1. Suppose we have given an array 1 1 2 2 3 3 5. We have declared two pointer means I and j. Our value I starting value will be a 0. It is a pointing to index, right? So it is pointing to index, and j will be the normal because to scan that array. I used to point the last unique element, means whatever the unique element it is coming from starting, it will point to that one. So at the end we will return that I, and j that used to scan all the array. So here we good to go. Array, we have array, and then I value is 0 starting and j value is 1. Fine. Step 1, j is equal to 1. When j is equal to 1 means we are starting with the j to scan all the value. So j is equal to 1 and I is equal to 0. So I is equal to 0 means 1 and j is equal to 1. Both are duplicate. If it is duplicate, we have to do nothing. We just increase the value of j and we will go to the next element. Next element we went and then we found I is equal to 0. 0 I have 0. Nums of 0 means 1 and nums of this time 2. So the both the value it has a 1 and it has 2, means both the values are different. So if it is different, we just increment the value of I. Currently I is pointing to this one. Now I will point to index 1. So I value is 1 and we just directly copy the I value, copy that whatever the j is pointing, nums of j is 2, we will copy the 2 into that I. So that array will look like this: 1 2. Initially here it is 1, here it is a 1 initially. So what we done, we just copy that whatever the j has, it copy to the I position, I index position with the value of nums. Again we will check. So now the j is pointing to 2 3, 2 we checked 3, 0 1 2 3, j is pointing to 2. So again 2 and I also pointing to 2 here. So both the value is 2 2. So in duplicate we do nothing, we just directly increase the j value and it go to the 3. So when j is 3 and I is pointing to this, again we saw the difference. So if we are seeing the difference, we are doing what, we just increment that I value 1 and we are storing the j, whatever j is pointing to this. So we increase from 1 to 2 I index value and we are copied that j value, means whatever the j has, j of is pointing to 3. So it will store directly to the I position. So it will come to 2 position. So now it will look like 1 2 3. So I is pointing to this and j is pointing to this 3. Again j is increased to 4. So j increased to 4 and I is pointing to this. Again different number, in different number we have to increase the I value. We have increased, I is pointing to 2. Now whatever the value is 4, that store in I. Now it will look like this: 1 2 3 4. Here 1 2 3 4 and now j is 4. So again when we see that j value is increased 3 to 4, then it will for duplicate, in duplicate we do nothing. Now we reach at the end. Now j cannot be increased further, this is the end of that array. So directly whatever the I is pointing, I is pointing to this index 3. So we will return as the length is always 1 greater than that index. So we are going to return I plus 1, that is 4. So our new array will be 1 2 3 4 and it will 4 length. Now we will start optimize coding whatever we, this one, okay, sorry, optimize solution we are going to write. Here it is same main method, we have declared array and we are passing in a method and we are going to call this method. This method will return the length of that new array which removed after the duplicate. So here we are using the 2 pointer technique. So as what we have done here, we handle here the edge case. So same thing here also we have to handle the edge case. We just copy paste that edge case code and now here we will write the business logic. So what is the business logic here? 2 pointer technique. So first pointer is I and the second pointer it will come inside that for loop, right? Second pointer is j and j will start from 1 because, and here the length of that size of, what is the name of that, names size of, length of the size of the array. And here we will write our logic. So what is the funda? We are going to check neighbors. If neighbors is a different, means we have a unique element. If it is unique element, in that case what we are doing, we are just increasing the I value, I plus plus, and we just copying the j, whatever j value is pointing. Means suppose I is here and here, the both value. So what we will do, we just increase the point of the I and we will just store that whatever it is pointing. So here we will check the condition if the neighbor are different, as this is the sorted array, so it is easy to detect the duplicate element. So both the pointer value is taken out and it is compared whether it is equal or not. If it is not equal, in that case we are just increasing the first pointer, and whatever the second pointer has a value we will store in first pointer's index position, and nothing we have to do. And here directly we can return first pointer with the I plus 1. Fine. As we know that at the end i's will point as an index, so we have to return the length of that array. Length of that array is always greater than index by 1. Now we can run this code. So to run this code we will going to write java. So here the new length is 4. Fine, we done this. So this is the 2-pointer technique, because first pointer is I and second pointer is j. We are playing with that 2-pointer, or you can change with that I equal to p1 p2. For your easy understanding I am changing these values. Nothing will affect, but just for better visualization I am changing. So as to easy to understand why it is saying 2-pointer. 2-pointer means it is pointing to two variable. Nothing, result will be the same. So that's why it is calling 2-pointer technique. Again I will repeat once more. So in 2-pointer technique we have seen brute force. What we have done in brute force, we have done nothing. We have just declared the hash set and we have stored all the value in hash set, because set automatically remove the duplicate element. So in that case the time complexity is coming n and space complexity is coming n, because we are using extra memory. And in optimized solution we are just using the 2-pointer technique. First is I and j. I will point to the last unique element and j will scan all the array. And what is the basic main idea that come behind in this picture, whatever the neighbor, if the neighbor is different, that means it has a unique value element. If it is not different, then it is a duplicate element. So our aim is to remove the duplicate element. So what we will do, if we will find the new unique element, in that case we are just removing the one pointer I, and then we are copying the I index position whatever the j index value has. So we directly, in that case we are just, time complexity is same, but we are just done with the no extra memory. Here we are done with the OFN. Now we are going to solve one question in a LeetCode. Remove the duplicate element from sorted array. So here what it is given, an array 1 to 2 to 4. We have to remove the duplicate element and return the length of that unique array. So whatever we have done here, we can just directly copy paste from here our code, and we can paste here nums. If edge case we are handle here 2-pointer, and then we try to run this code. Yeah, all test cases submitted, accepted. Let's submit. Boom, we almost pass all the test cases. So thank you for watching this video. If you like, please like and subscribe, and do share with your friends.